the sun. We know that is the source where we get energy from the fusion reactions. So fusion energy is not new to us, but the difficulties we have is to how to make these man-made stars on the Earth. Under the support of the Fedoruk Centre, as well as the University of Saskatchewan, and our industrial partner, Plasma Ionic in Quebec, we are able to further our study in this area. As we know that we have about a couple of billion people on the Earth. If we extrapolate or project how many people population we are going to have in 100 years, with a very conservative estimate, we probably is going to saturate at about 10 billion people on the Earth. That represent a great difficulties for the energy supply. The current energy sources, mainly from the carbon-based source, like the coal, oil, natural gas. We know we worry about the carbon CO2 emissions, the green gas. So our prediction is we're going to use less and less of those carbon-based fuels. On the other hand, also those fuels will eventually depleted, so we have to find the new energy sources. Currently, we're using fission reactors for generating electricity. We don't see that is going to go away. We are going to see probably it's going to use until we lose all the resources. The ultimate solution to the energy problem probably will be this yellow column of fission energy. However, we know that is quite some years away. It's a strategic research direction we should follow. So this is a kind of the diagram shows how that is going to work. It's not too much different from what we have in a fission reactor. The only difference is the fuel we're using is different from the uranium, which Saskatchewan is fortunately have lots of production. The fuel we're going to use, one side is from the heavy water in the seawater, the deuterium or heavy water that is part, a small percentage of the seawater, but it's still very abundant. The other element we're going to use is the another hydrogen isotope. It's called tritium. This one. This is not naturally existing because it's radioactivity with the 12 years half-life. However, we can breed the tritium from the lithium, which is abundant. So the message I would like to tell you is the fusion reactors have lots of advantages, including the abundance of the fuel supply. Also, these reactors are intrinsically safe. You don't have meltdown risk. The other thing we have is, or we don't need to worry too much, is the nuclear waste that currently we worry about in the fission reactors. In the fusion reactor, that is not a major problem. So next big project that one of the devices for fusion reactor studies, or the promising device, is called a tokamak. Another message I would like to convey is Saskatchewan has actually over 40 years of research history of fusion research. And we are now working on several projects. One of them is how to fill the tokamak.